Let me start off quickly by saying, if you're afraid of algebra, do not enter. Go away. No, I'm just kidding. I just want to show you that where this equation for scalar product or dot product came from. Remember, we've been using this in previous videos. We've been looking at this, but I want to show you where this came from. It did not come from outer space. It actually has a derivation. So I want to show you this, and it comes from here. So where does a scalar product or dot product equation come from? I love this meme here. Derive all the equations. That's sort of how I feel right now, right? We're gonna do this. We're gonna do it. We can. This actually is a meme from, I think originally the picture came from a blog called Hyperbole and a Half. Highly recommend it. Super good. I don't know if she's been posting anything recently. A couple years ago, I think she stopped. But really, really funny. Anywho, someone did derive all the equations. I thought that worked. So let's do it. Let's figure this out. So we're going to start with a vector A, and it's going to be a generic, general, regular old run-of-the-mill vector, A1, A2, and we're going to have another one called B, which is B1, B2. And we're going to start by putting those tails together. So what I mean by that, let's see here. I'm just going to start by drawing this one. I'm going to copy that, and then I'm going to paste that. Good. There we go. There's A. And I'm going to also do the same with B, sorry. There we go. There. So I'm going to put them together because I'm going to try to do some geometry with them. There we go. So there we go. This is good old A. This is B. And I'm going to try to do something. Now there's an angle between them. What I'm going to try to do now, though, is use these in a hopefully clever way. I want to try to figure out what this one right here is. This is the vector. Now, I can't really define it going from A to B necessarily. Well, it's going from point A to point B, yes. But I need to define it more smart than that, you know. Well, that wasn't even a very smart way to say it. How ironic, right? I need to define it a little bit better. So what I'm going to do, I'm going to draw myself a little arrow. There we go. And I'm looking for a way to define this thing right here. This vector going from the end of vector A to the end of vector B. This is the one I'm interested in. I want to find out what this is. So what I'm going to do, this is what I'm interested in, right? I'm just going to state that right now. I want to find this value right here. In order to find the angle, I'm going to need to know, what is this? I want to know this. How do I define this one? So I'm going to take a few things now. I'm going to take these tools again, and you're going to think this may be a bit time consuming. I'm just going to show you what I'm going to do with them. I'm going to take this one, I'm going to copy that one and paste it again. I just want to take all the pieces and make sure that all the players are here. And I need a B. Go. Good. All right, I got all my pieces that I need here. There are my sticks. Here are my pieces. So what I want to try to do, remember we were doing this in another video too, and I was showing you how to add or subtract vectors. I could do, remember the one that goes down and right, that's B. The one that goes up and right is A. And then this other one, I don't know what to call it yet. This is this vector going somehow from A to B. Well, I suppose I could call it that. It's a vector going from A to B. But I want a cleverer way to define it. So, I could try to do B plus A, but that gets me a vector that goes all the way over here, from the start to the end. That's a vector goes to the right. I don't want that. I want something that goes down and right like this. I want this one. That doesn't work. What if I started with A and I did A plus B? Oh, crap. That's the same thing. Look, it still goes to the right. So that doesn't work. But remember we learned before that what you can do, however, you can take A and you can flip it twice. So this is, I'm going to take negative A. This is what I'm trying to do here. There we go. So I'm trying to take A, but instead of going up and right, it goes down and left. This vector is negative A. So what I'm going to try to do now is do B plus negative A. Look at this. Look at this. These work. So what this tells me then is that, maybe I better label all my little fellas here so that I know what's going on. This is B. And this one is negative A. And that means this right here, this is the vector that I wanted. Well, then this is B plus negative A. That's what this is, right? This is how we write this vectorially. We say B plus negative A, that's this thing. So that means, this is really important, this helps me. So I can say B plus negative A, Or if I'm feeling really lazy, I can actually say, therefore, this whole thing, I'm going to define it then as b minus a. I'm just going to say it's that. All right, so that's important. That's this piece right here. I'm going to define it as b minus a. That's this vector here. Now, why would I care about any of this? Well, that's because now I can start working with it. I can use the cosine rule. And I'd maybe better remind you about the cosine rule. And maybe I'd better also take, maybe I'll take this piece right here. So I'll try to copy this thing right here. There we go. I'll attempt to do this. Let's see if it works. If it doesn't, I can just redraw it in a second. Oh, that worked. Although, can I grab it all? Or will it all screw up? Ah, darn it. Oh, well, it's okay. I can still re-put it. I can put it all together here. Oh, God. Actually, I don't care about this stuff here. All right, let's just say we go like this. I can do cosine rule with this one. I can do it easily. I don't need any of this crap here. There we go. So we'll just cut those out. So what do I have here? Here I have this one right here. I'm going to define it. I mean, if I was just drawing a regular triangle, let's remember what cosine rule is. Okay, so maybe off to the side I'm going to do this. I'm going to do this way over here, just to remind you about cosine rule. All right. So if we had a regular old triangle, and I'm going to take this whole thing and I'm going to copy it, and I'm going to paste it. I'm going to need it one more time. I'm going to put it over here to show you what's going on for reals. But for that, here, I'll just move it down. So let's start off with this. This is a regular old triangle, and if I was going to do that, I could say that there's an angle theta. This is like back in the day here, you're learning about cosine rule. And cosine rule would be defined as such. We would say that this right here would be some angle. We would even, instead of calling it an angle theta, let's even call it something else. We can be even smarter than that. Well, we can do sort of the old school way of naming angles. We could actually name something. We could name this, how should we do it? Yeah, let's do it like A, B, and C. Those are the vertices, and those would then be called the angles between them. This would be like angle C, and this would be angle B, and this would be angle capital A. And then the convention then is whatever's opposite to it, we name that little side. So we call it little a, and opposite to B would be little b, and opposite to C would be little c. Those would be the lengths of them. And if you remember cosine rule, it goes like this. You don't have to trust me. I've got another video on it, but here it is. It says that C squared, in other words, this little side right here squared equals a squared plus b squared minus 2ab. Oops, I guess I don't need all the brackets going on here. So equals minus 2ab cosine of capital C. In other words, cosine of angle C. So this is what we have. We have side C squared is equal to a squared plus b squared minus 2 times side A, side B times cos of C. This is the cosine rule. Now, how do we have it over here with our vectors? Well, over here we have vector A. Here we have vector B. And over here, what we just defined it, we defined this other weirdo one as b minus a. So I'm going to define it as such then. So b minus a. This is sort of one thing together. You can't split it. We're going to just keep it the same thing here. We're going to keep it all together. Well then, this means now this is going to look really messy. We're going to start off by doing some stuff here. So hold on to your hats. This is going to get a little bit algebraically ugly, but we're going to hopefully get our way out of it. And by the way, we have this angle right here. We're going to call that angle theta. That'll be our angle C. Okay, so I'm just trying to have you see, that this one over here is done by the cosine rule. So this sort of came from this old blast from the past here, okay? So this is something you need to use. So what we're going to do then is we're going to hold on, take our time, and really go nice and slow and try to figure out how to deal with this. So we got C squared. Well, let's deal with that. What does that mean? That's this side. Anywhere I see a C, I replace it with b minus a here. So I'm going to say, all right, that's b minus a. And I'm going to, remember, this is its length. So even worse than that, because this is a vector, this is a vector, this is a vector, but I need to know its length. How do we find the length of a vector? We do the magnitude. So that means we've got to do this thing. Remember what this thing means. That's a square root of the sum of the squares. Oh, God. So, yes, we're going to do b minus a, and we're going to do this magnitude. And we got to take that thing and square it. All right. Equals, well, we got to do a squared. So that would be the length of this one squared. Plus b squared, which is the length of vector b squared. Oops, I got to remember my vector notation. There we go. Minus 2 times the length of a times the length of b times cosine of the angle. This is what I'm working with. I guess I shouldn't end a sentence in a preposition. This is, forget it. This is what I'm working with. So then what I'm going to do, I'm going to say, all right, how do I deal with this? Here we go. I'm going to remember then, how do I do a b minus a? Well, you kind of got to remember what b minus a actually means. Let's maybe do this off to the side. But this b minus a, what does that really mean? I can define it as, if I actually want to take, a vector going from a point to a point, we've learned also, this uses everything we know about vectors. This uses magnitudes and angles. This is great and terrible at the same time. This, in order to find the length of this right here, well, we've got to do b1 minus a1. This is how we would do this, right? We would take whatever first value, and we would take b2, whoops. So I'm trying to take this right here. This is the vector form, but I want to do it in component form. So I no longer want the vectors. See, I want to get rid of the vector symbols, and I want to break in. So this is b2 minus a2. That's what this means here. So instead of vector b minus vector a, I can say it's b1 minus a1 and b2 minus a2. Just like this one right here is actually a1, a2. And this is b1, b2, and so on. So I'm going to take all these and start to work with them. I'm going to attempt this. So we're going to simplify things, or at least attempt to simplify. So maybe I need this little piece right here. I'm going to take this, and yeah, I'm going to have to simplify here, that's step 4, but I'm going to start simplifying right over here. So, hold on, here we go. In order to take the magnitude of something, I've got to do the square root of the sum of the squares of each of the components. So this is going to be b1 minus a1 and all that squared. And then I got to do plus b2 minus a2 and all that squared. I got to say that thing equals, and then I got to work with a here. This one right here, how do I do the magnitude of a? That's the square root of, thankfully this one's a little bit easier, a1 squared plus b1 plus a2 squared. That's right, I got to remember how to do this. There we go. That's this one. But don't forget, because I just forgot, I got to do this whole thing, remember, this whole thing squared, because that was this squared up here. So this whole square root squared. I got to do this whole square root squared. I'm just trying to show you where everything came from. And you might notice, hey, a square and a square root, they undo each other, don't they? Yes, yeehaw, these ones at least undo each other, thankfully. But just to be complete, let's keep going. Plus, and I've got square root of b1 squared plus b2 squared. All that quantity squared, but thank goodness, those disappear. Then I got minus, whoops, I may as well keep it in black. Minus, I've got 2 times. Now what I'm going to do here, I'm going to be a little bit sneaky. I'm just going to leave the a here, and I'm going to leave the b, because I don't feel like anything else here. So I'm just going to leave those. It turns out I'm just going to leave them because that's how we're going to get the equation to work. We're going to work with these things here that we can work with, and hopefully we're going to see that these are going to stay. Of course I could have dealt with each of these as well. This would have been a square root. This one is a square root of a1 squared plus a2 squared, and so on. Sure. So I'm just going to leave these ones there, because I'm just feeling a bit lazy, and it turns out I also know what the answer is going to look like, and if we keep them like this, it's going to be much more simple. It's going to be beautiful. Right now it's pretty ugly, and it gets even uglier, because now what I got to do, I've got to deal with this thing right here written twice. Maybe now is a good time to take this whole mess here, copy it, and bring it over to the other page. Let's bring this party over to the next page so we have some more room here. Let's do this. Paste. I lost a few of my 2's, didn't I? But oh well. They weren't needed anyway. I didn't care about them. There was a 2 here, there was a 2 here, and there was a red line here, and there was a red line here. There we go. Now we got everything we need. Here we go. So, remember though, this thing squared is not just this squared plus this squared. And this isn't just this squared minus this squared. You gotta, it's important to maybe write them out twice. If this whole thing is squared, remember how to square a binomial. It's really important to be very careful. Plus b2 minus a2 times b2 minus a2. I'm just going to work on this left side because it's really ugly. We're going to leave the right side the same way. Well, thankfully, these all disappeared. So this is just a1 squared plus a2 squared plus b1 squared plus b2 squared. We're almost there. It's going to get uglier, and then it's going to get a lot better. Minus 2 times a vector times b, magnitude of that vector, times cos theta. Whew. So how do we deal with this? Well, I don't know if you've ever heard of FOIL or first, outside, inside, last, but either way, you got to multiply each of these terms by each of the other ones. So I'm going to do b1 times b1 is b1 squared. Then I'm going to do b1 times a1. That's minus a1 b1 minus a1 b1, because I got to do the inside. And then minus a1 times minus a1, which is plus a1 squared. This is this thing here. And let's deal with the second one here. So this, by the way, this mess gave you this mess here. That's this. And this over here, let's see what that one gives you. This one is going to give you something else. Let's see what it does. So this is b2 times b2. Boy, I hope I didn't make any mistakes. I guess I'll notice later. Times, let's see, a2 b2. So that's minus a2 b2. And it happens again, minus a2 b2. If you're really good, you'll say 2 in front of it, but we'll do that in a second. Minus a2 times minus a2 is plus a2 squared. And all that, of course, equals the same mess over here. I don't feel like doing it right now. We'll just leave it. Maybe I should, just to be complete. I would be upset with myself if I didn't. Minus 2a b cos theta. All right. Now what can we do? We can now combine these a little bit. We can say b1 squared. And this here is minus 2a1 b1 plus a1 squared. I'm just combining these two right here now into this one. By the way, this right here made this mess right here, just to show you where the messes went. And this one right here, maybe I'll do it in green. This one right here led to that one. And let's see now, this one here is plus. I'm just trying to keep the spaces so we can keep track of all of our players. We have minus 2a2b2 plus a2 squared. That was this mess right here, became that. And of course, that's a1 squared plus a2 squared plus b1 squared plus b2 squared minus 2a b cos theta. Phew! Thankfully, some nice stuff is hopefully going to happen. Let's see what happens. Well, what do we have going on here? We've got some terms canceling out, I hope. I've got a b1 squared on this side, and I've got a b1 squared on that side. Hey, hold on. That means this guy cancels out that guy. And the a1s can cancel out, I hope. I don't know what colors I should use. Will yellow turn out okay? That looks really bad. I'll try red. I haven't done that in a while. So a1 squared cancels out that a1 squared. All right. How about a b2? Do I have any b2 squareds? Yes, I do. So I've got a b2 squared. Maybe I'll use a green one for that. b2 squared cancels out that b2 squared. Well, that's pretty nice. And I've also got an a2 squared. Maybe I'll use blue for that. So a2 squared and that a2 squared. Oh, thank goodness gracious, that looks a lot nicer now. So now I've got minus 2 and a minus 2. I can actually put those together even. So I can say minus 2, and I can say a1b1 plus a2b2. I'm combining terms here. I'm combining what I've just done here. I've combined this one and this one together. That's what I've just done there. So now I've got minus 2 times a1b1 plus a2b2. And all that equals, don't forget about the right side. Can't forget about our trusty right side. And the right side equals, oops, I need the right color of pen. We're almost done now. So minus 2 times the length of A times the length of vector B times cos theta. Well, take a look. This minus 2 cancels out that minus 2. That means I've got A1, B1 plus A2, B2 equals absolute value, or not absolute value, sorry, magnitude of A times the magnitude of B times cos of theta. And if we defined some special little thing that we called, hey, instead of this, what if we called this A dot B? Turns out this is how you do it. This is the answer here. We get, whoops, there we go. Do you see the similarity? See, we got AB cos theta, we got A1, B1 plus A2, B2. In other words, that's what A dot B is. If we just called this thing A dot B, we got A dot B equals length of A, length of B times cos theta. Take a look at this. Check a look doesn't make any sense. Take a look at this. We've got V dot W equals, and remember, V dot W is just, all these things right here. So we've got them all combined right here. We've got it all figured out. We've actually done it. Yay. So we've done this. We've actually figured out this is where it came from. Ta-da, we're done. Yay, big giant smiles. And you might be totally tired after watching a 21-minute video all about a proof of where an equation came from. You might be wanting to vomit rainbows. Well done for making it to the end of this. Well done.